Hello users, nice to see you on YouTube. This right here is the B.Tech second year hostel in NIFFT Ranchi. Myself P. Satish Kumar, and right now we are here to guide you through the basics of a robotics event and how a bot functions. For that, first let me introduce you through my team. First of all, we have Vinod Kumar, hi, assistant driver. Then we have Chandraveer Singh, hi, the bot driver. He is the man behind the bot movement. Then we have assistant Ram Singh and Prakash. Hi. Together, we will show you how basically a bot works, what are the prerequisites for setting up a bot, and how it should be properly conducted through an arena. First of all, this right here is a robot. As you can see the structure, the entire frame is made up of deodar wood. Then you can see up here is some complex wiring held together by some good wiring over here. Then these two are two indigenous arm systems of this robot. Now what actually drives this robot is this adapter. This non-conventional adapter made of hand actually uses a 12-volt supply and a 6-volt supply, both working out for their specific programs. That can be directly connected to an AC socket. So let me first guide you through the basic structure of the bot. The 4 wheels over here use 4 motors, which again are guided through some complex wiring attached to the incoming wires from the adapter. The same holds true for the 2 arms over here. And the power supply of each motor depends upon what kind of job each of them perform. For example, it is always advised to use the optimum motor rating of 100 RPM to drive the robot. The arms can be of 30 or even 10 RPM as depending upon what kind of job they do. Now let us demonstrate you the fundamental operations of the robot. When you propel all 4 motors in forward direction, the robot executes forward motion. As you can see, our bot, the METALLIKNIGHT, has begun its operation. The same, if all the motors are propelled backward, then the robot executes backward motion. Now, if you fold back one pair of the motors and drive the other 2 to find left side motion, just the vice versa executes the right side motion of the bot. And using the similar mechanism, we can also move to and fro our arms over here. First going with this arm. This arm was specifically designed to burst a balloon. Unfortunately, we have run out of balloons over here, so we will be demonstrating you this arm. This arm can execute similar to and fro motion, but the special attraction over here is this gearbox, which is specifically fit to make this claw mechanism move. This is especially useful when your bot is designed to pick any job. For example, right now I'm going to ask my driver to pick this cube up here. Now before he begins, I would like to tell all the novice interested robotic learners watching this video, the basics of making a bot successful in an event is the coordination between the team members. The driver and the guy holding the wires must have good coordination between them. The driver must use his own confidence to decide the movements of the bot. Plus, the guy holding the wire must always ensure the wire is slack and not tight. Because in most of the events, if you hold the wire with tension, they consider that it is a symbol that you are actually pulling or pushing the robot. So your marks go off. So always ensure that the wire is held slackly, as we know this is doing perfectly over here. Now to begin the robot motion, the first thing Chandraveer must ensure to pick up this cube over here is that the bot approaches it properly. As we can see, and when he approaches close, this is the arm that actually moves while this stays stationary. So it is necessary to ensure that this thing actually properly grips over the cube, after which you can close in with this. A bit of right, bit of forward, bit of right again, and then fixing it. Now, whether to test that your job has been perfectly held or not, I would always advise the user to pick up and release the cube to ensure to see whether your claws actually held it firmly. Because when the driver and his assistant stand from a specific distance from the bot, they cannot just rely on their visual information that whether the cube has been perfectly held or not. Sometimes it may apparently seem as if your claw has perfectly fixed it, but when it picks up, you may find something which you don't like. Now, once he has picked up the cube, now let us focus on a drop zone. Not only is picking up important, but dropping it safely is equally important in a robotics event. While you have your cube in your arm, I advise you not to undergo any unnecessary motions with the bot, for that will lead you into turmoil and you might face some negative marking. Now the second thing which we must consider properly is to properly approach towards the drop zone. If you can begin a motion. If I say this over here is the drop zone, so first one thing must ensure is that to put the arm forward. Put the arm forward to ensure that the driver gets a proper view, proper estimation of how far is this arm and the cube from the drop zone. Now once you place your cube properly on the drop zone, then you can rely upon your claw to actually release it. And once you have released, this right here is the most important part, to take your bot away safely with the arm wide open. Sometimes it happens that even after you have put your job over here, if some part of your arm is in contact with the cube, even when you drag it back, the arm actually drags your job away from the drop zone, which is completely unwanted. This is something which the driver must take care of. Now as you can see, both the claws are independent and at a safe distance from the job. The robot can be propelled backwards. When you do this, I'm pretty sure if you follow all these instructions, you can safely land up in any robotic event. Thank you for paying visit to our video, and the credit for shooting all this goes to our cameraman who has been patiently doing it, Saurabh Rana.
Thank you. Bye.